Welcome to the Astro. In this Python tutorial on Photutils for photometry of stars and galaxies. So in part 1, part 11, we will be learning that how to do source extraction from the fits image file and how to create a segmentation map of these sources. Segmentation map does it that it separates the sources from each other in the pixel space. So for doing these extraction and making segmentation map, we will be following these 5 steps. So first we will be defining threshold above the background noise, which we have calculated in our earlier tutorial on Photutils, and then we will create a 2D Gaussian to convolve it using our data with the Gaussian kernel, and then we will detect sources using those threshold and convolved data, and then we will plot segmentation map to show the images in a distinct way from each other. So let's do it step by step. So first I will define my threshold. So I will give a parameter, say threshold or th, or simply just write here threshold equal to, I can give say 1.5 into our background, okay, our background RMS. So this will be our detection level, and you can see what is my background RMS from our earlier result. This is our background RMS for every pixel. So if you print it, so threshold, and if you run it, you can see for every pixel there is a threshold. So if the pixels are above 1.5 times RMS background, then it will detect those pixels as a source. Okay, now we have done this part. Now create a 2D Gaussian kernel. Okay, so for that I will import some libraries. So I can make it so from Photutils, dot segmentation map, segmentation import and make 2D Gaussian kernel. Okay, now we have done this much. Now what I will do, I will import one more library to convert the data. So from Astropy dot convolution import convolve. Okay, now these two libraries are imported, and now I will create a 2D Gaussian. So define kernel equal to make 2D Gaussian kernel and function, and see what it takes. So it will take your FWHM and size. Okay, so it will take FWHM and size. So FWHM is you can give some pixels and size you can give, okay, as a 2D array, as a 2D data. Now, so I can give say 3.0 as a FWSM, and size I can give equal to 5, right? So here 3 is FWSM. Now we have make a 2D Gaussian kernel, and then I will convolve the data. So for that I will type here convolve data, right, equal to convolve and function, and see what parameter it takes. So it will take array, the image array, kernel, and so I will give only 2 things right now. So for that I have my image subtracted data. So here you can check it. Here I have my final data as the array. So I will go and put it as final data, and then I will pass my kernel. Now run it, so you can check it what is your convolve data. So this is the array we will be producing. Now we have done. Now we'll be detecting sources using those convolve data, okay. So for that use here library from segmentation from Photutils dot segmentation import detect sources, okay. This will detect the source, this library, and then I will create say seg underscore map equal to detect sources, and I will pass my convolve data and threshold. So threshold I will threshold, and you can see what parameter it takes. You can check it here. It takes data, threshold, in pixel, kernel, etc. So I've given the threshold, and I will give say in pixels, okay. So in pixels I can give say 10 pixels I've given. Now run it. So if you run if you check what is your segmentation map, so you can see our image, this image. So I can go here and you can see this image in which we have subtracted the background. So this image has size of shape of this array x pixel and y pixels, and it has in label 033, means it has detected 333 objects, okay. So I can write a comment. It has detected 330 objects, right? So you can give the numbers label. Now I'll plot this map, okay. So for plotting I will add a plot it, okay. So for that use plot image. So plt dot image show, and I will pass my segmentation map, 2D map. So, and run it. So here you can see that you have image, okay, and it has been separated. You can see the object are now separated from each other, okay. You can give a color map to this to visualize in a more so C map equal to, you can give sig map dot C map. Okay, so here you can see that objects are like looking in a more good way, right? So you can also give any color map. You can give color map. You can give, say, jet. So here the images are, okay. This way you can detect the sources on that feeds image. You can also make a color bar. So plt dot color bar, you can make it. You can see that the color bar is going from 0 to 330, and like every color is representing a different source, okay. You can make it rainbow. So here is the source, okay, with different identity on the pixel space, right? So this way you can create a segmentation map from the feeds image on the background subtracted data. So we can summarize our work. So first we have defined our threshold for the detection for every pixel from background RMS, and then I have created a 2D Gaussian kernel, and then I have done convolution with our data and kernel, and then I have detected sources using convolution data and threshold and minimum number of pixels. So we got 330 sources from this source detection, and finally I have created the segmentation map of the objects. So thank you.